Welcome back to the video series on Atmel Studio 7 and Atmega 328P microcontroller. So here I'm trying to get this LED attached to port D pin 5 of the microcontroller to respond to a push button attached to port D pin 3, which is an interrupt pin, and when the push button is pressed, I'm gonna toggle the status of the LED. So that means when I press the push button once, if the LED is off, it will turn on, and when it pressed for the next time, if the LED is on, it will turn off. So at every push button press, LED will change its state. So in order to do this, I have created the flow chart. So the flow chart is divided into two parts. First part is our main program. As usual, we are running a never-ending loop, and in the second part I have the interrupt service routine. Interrupt service routine is the part of the program which will be executed when the interrupt occurs. So what is an external interrupt? External interrupt is something which is coming from outside of the microcontroller. So here it is either a rising edge or a falling edge for a particular state which is input to the microcontroller from an interrupt pin. In this particular microcontroller, we have two interrupt pins, int0 and int1, which are second and third pins of the development board. O, they are port D pin 2, O and port D pin 3 of this microcontroller, which is Atmega 328P. So in the main program, when the main program starts, we have to configure the external interrupt, and then we have to set the data direction of the port attached to the LED. So that is port B pin 5, and then it comes to the never ending loop, and it will be waiting at the never ending loop. So when the push button is pressed, then the interrupt will occur. So once the interrupt occurs, we will go into the interrupt service routine, and in the interrupt service routine we will check if the port B pin 5 is high. If it is high, we will put it to low. If it is not high, that means if it is low, we will put it to high. And once the interrupt service routine finishes, it will come back to its normal loop. So that's how the program is. And in order to configure this external interrupt, we need to know a couple of things. So one is how to enable this external interrupt. So enabling the external interrupt is done using this EIMSK, external interrupt mask register. So since we are using external interrupt 1, this particular int1 bit should be set to 1 in the EIMSK register. And there is another setting, that is whether we are triggering the interrupt when the push button is pressed at the rising edge of the input signal, or at the falling edge, that means when the push button is released at the falling edge, or when it is at the low state, or we can even set the interrupt to trigger at either of the edge, that means at rising edge or falling edge, any of the edges. So that is being set using this EICRA register. In that one, these first two bits are corresponding to external interrupt 0, and the second two bits are corresponding to external interrupt 1. So since we are using external interrupt 1, we have to set these two bits. So the settings are, if they are 0 0, we are triggering at the low level of the signal. If they are 0 1, it will be triggering at any logical change, that means whether it's from high to low or low to high. If it is 1 0, it will be triggering at falling edge, and if it is 1 1, it will be triggering at rising edge. So I'm trying to change the status of the LED at the button press, so that is a rising edge for the input signal. So I will have to set these two to 1 and 1. So the settings will be in the mask register EIMSK, this bit should be 1. In this register, these two should be 1. So let's go to the program itself. So in fact, I have written the program here. So as usual, we have to set the processor speed, and the hardware definition should be there. That means we have to include the io.h. Since we are dealing with the interrupt, we have to include interrupt.h header file as well. So I will explain this volatile definition later. And in the main program now, I'm trying to set my interrupt, so configure my interrupt. So here I'm setting EICRA registers second and third bits to 1 corresponding to the rising edge, and I'm enabling my external interrupt 1 by setting the first pin of EIMSK. And there is something called global interrupt. That means there are so many interrupts, all those interrupts can be either enabled or disabled by something called global interrupt. So that global interrupt should be enabled if you want to enable any of the interrupts. So enabling each of the interrupt won't be enough to trigger those interrupts. Every time if we want to use an interrupt, we have to enable this global interrupt as well. So in this particular IDE, we have to use this SEI command to enable global interrupts. So now we have enabled global interrupt, we have enabled particular external interrupt, we have done the setting to the rising edge. Now the interrupt is ready. Now we have to set our LED port, that is port B. Port B, what is the pin that it is attached to? Port B, the external pin is port B pin 5. So port B pin 5 as output, right? So we have to enable port B. Sorry, I think I looked at the wrong image. Let me see. Yeah, we have to enable port B pin 5 as output and enable, and that is all in fact. So we have to enable port B pin 5, port B pin 5 as port B pin 5 as output. So this is output. Anyways, we have set it to output. So I have set this one to input, which is not required in this case, and I have set this particular port D pin 3 as input, which is in fact not required in this case, but I have done it. So if we want, we can even comment that out, that is not required. And we are going into the main loop. So we have configured the interrupt, we have set the data direction, and we are going into the main loop. And now while we are waiting in the main loop, we have to, if the interrupt occurs, we have to go run the interrupt service routine. So this is the interrupt service routine. So interrupt service routine in Atmel Studio 7 is written like this: ISR within brackets, we have to give the particular interrupt names, interrupt vectors name. So these are in fact configured in this particular io.h. So int1 underscore vect is the interrupt vector for external interrupt 1. These are available at the datasheet. Now inside this particular ISR, sorry, in fact I don't, this has done for testing, this is not required. So I have defined a variable called toggle. So you can see the toggle variable I have set to 0 in the beginning. So here what I'm doing is, if toggle is 1, I'm setting my port B pin 5 to 1. Else, that means if toggle is 0, I'm setting my port B pin 5 to 0, right? So if toggle is 1, I'm setting it to 1. If toggle is 0, I'm setting it to 0, and I'm changing the status of the toggle afterwards. So that toggle equal to toggle 1 minus toggle means if toggle is 0, it will be 1. If toggle is 1, it will be 0, right? 1 minus 0 becomes 1, 1 minus 1 becomes 0, right? So the value of toggle will toggle every time it comes into the interrupt service routine. So based on the value of the toggle, I'm changing the status of the sorry, I'm changing the status of the LED. So if the status of the LED is 1, I'm turning on the, so if the status of the toggle is 1, I'm setting the LED to on. If the status of the toggle is 0, I'm setting the LED to off, and I'm changing the status of the toggle, right? So every time when it comes in here, the value will change, right? So because of that, the LED should blink. Now this is the program, so I will build the program here. Build solution. Let's wait until it builds. Okay, it finished building. So we will try to create this particular schematic capture. I'm going to attach this one to the particular pin. Okay, now I have attached the LED to pin 5, and I have attached the push button to pin 3, and I have to now sorry, set this to external interrupt. So this is the one that I have compiled right now. Okay, and I'm going to run the simulation. Sorry, simulation is running, so we will see if it is working. See, LED should change its state. See, now you can observe when I press, it changes. Now it won't change. Even if I release, it won't change. When I press next, it will change again, right? So the LED is responding to the push button. We are using an interrupt to do so. So I have shown you how to write the program. So try it out. Thank you very much.